Test hypothesis about a population standard deviation. To test hypothesis about the population variance or standard deviation, we're going to use the following steps, provided that the sample is obtained using simple random sampling or from a randomized experiment, and the population is normally distributed. Step number 1, we need to determine the null and the alternative hypothesis. The hypothesis can be structured in one of three ways. If we have a two-tailed, we know that the null hypothesis is the following, where you have equals, and then the alternative is not equals. The left-tailed, we will see that the null has an equality, and the alternative has the less than symbol. And the right-tailed, the null has the equality, and the alternative has the greater than symbol. And note that the variance, or the standard deviation, subscript 0, is assumed value of the population standard deviation. Step number 2, we select a level of significance, alpha, based on the seriousness of making a type 1 error. Now, on the left-hand side, we're going to see the classic approach, and then we'll come back to the p-value approach. Now, the classical approach, we need to compute the test statistic by using the test statistic formula. And then we're going to use the table to determine the critical value using n-1 degrees of freedom. Now, if it is a two-tailed, that means that we're going to have two particular areas in the chi-square graph. So we're going to have two critical values, meaning we have two critical regions. With the left tail, we only have one critical region where the critical value is located on the left side of the chi-square distribution. And in the right tail, we have a critical value on the right side where the critical region is on the right side. And then step 4, we're going to compare the critical value to the test statistic that we got from step 3. Now, if the test statistic is less than the critical value, or the test statistic is greater than the critical value here on the right, then we're going to reject the null hypothesis. Left-tailed, if the critical value is less than the left critical value, then we're going to reject the null hypothesis. On the right tail, if the test statistic is greater than the critical value on the right, then we're going to reject the null hypothesis because it falls within the regions. And in step 5, then you're going to state the conclusion. Now, if we want to use the p-value approach, we're still going to be able to then compute this test statistic like we did over here. And then we're going to use the table to approximate the p-value for a left or a right tail test by determining the area under the chi-square distribution with n-1 degrees of freedom to the left for a left tail test or right for a right tail test of the test statistic. Now, if it is a two-tail test, then we need to multiply the p-value times 2 in order to get that p-value. So now if it's the left tail test, we have our test statistic and we want to find the p-value to the left. And if it's a right tail test, then we have the test statistic and find the right area to the right. And again, if we have two tails, then we got to be able to then multiply whatever tail that we're looking for by 2. Now, in step 3, we can use technology. So we're going to use StatCrunch to obtain the p-value. And so there will be directions that I'll show you in the example to obtain the p-value in a step-by-step instructions. Now in step 4, if the p-value is less than a significance level, then we're going to reject the null hypothesis. And then in step 5, you would state the conclusion. Now, the methods presented for testing a hypothesis about a population variance or standard deviation are not robust. Therefore, if analysis of the data indicates that the variable does not come from a population that is normally distributed, the procedures presented in this section are not valid. Again, always be sure to verify that the requirements are satisfied before proceeding with the test.